That'd be embarrassing. All right, guys. So let's get started with these probability definitions. These are, again, going to be just definitions. You might want to write little notes about them. So like the first one is the sample space. And this is everything possible. So when we say sample space, we're talking about all possible outcomes. When you do a chance experiment, what's a chance experiment? It's when you do something like rolling a die or flipping a coin. Those are chance experiments because there's a chance that multiple outcomes can happen. So sample space is the collection of all those possible outcomes. So if you're talking about like a die, the sample space would be 1, 2, 3, 4, 5, 6. Those are all the possible outcomes. We usually use S to denote sample space, but we don't have to. S is just like, starts with the letter S. So it makes it easy for people to recognize, that's the sample space. But these are all possible outcomes in this chance experiment of rolling a die. You can do this with many, many things. The sample space is everything that's possible. An event is something inside the sample space. Specifically, like rolling a 1 or rolling a 2. Those would be events. And probability is not super intuitive for a lot of people. You might have to work at it a bit for things to start clicking. But once it does click, I promise you, it's very logical. So here would be the event rolling a prime number, which would be, they've decided E. They could use any letter they wanted here. They chose E. And these would be the prime numbers on a die. A prime number is anything that has a factor of only 1 in itself, not including 1. So 1 is not prime. So 2, 3, or 5 would be the event E rolling a prime number. This would be a compound event rolling a prime number or an even. And so that would be the primes, which are 2, 3, and 5, along with the evens, which would be 2, 4, and 6. And a note you might want to make is that we don't write the number 2 twice. Even though he's in both groups, prime and even, we only write 2 once. Feel free to interject if you have questions too. If something doesn't quite click, I can adapt to whatever might be perplexing you. All right, let's keep this going. So a simple event, just like it sounds, and it's only going to have one thing in it. It's simple. Rolling a 2, rolling a 5. That's a simple event. There's going to only be one thing inside there. And again, we can use any letter we want here. They chose E, but you could say the simple event B or S or T. Usually we would reserve S for the sample space, but you really can define it as however you want. All right, so new definition, the complement. You've heard complement before in your geometry class, and that was any angle whose sum added to 90 degrees with another angle. So those would be complements of one another. In probability, they're going to add up to 100%. So a complement is everything that is not in the event. So if you take an event and its complement, you get everything possible. So not rolling an even number, which is denoted by E complement, E to the C right there, would be the space 1, 3, and 5. E would be 2, 4, 6. Together, they make everything possible. So a complement is the exact opposite of an event. All right, next up, the union. So the union is when you put an or between two events. A or B would be the union of A. And I don't want to say and because we're going to use that in a second, but the union of A or B is what we're going to be talking about. And this consists of all outcomes that are in at least one of the two events. So I think I heard Schmerker, when I watched him a couple of years ago teach this, he's like, think about like a union, like a marriage. When you get married, you bring everybody's stuff together. You got like all of her possessions and all his, or all of his and his, or whoever's, but everybody's possessions get brought together when you have a union. So rolling a prime number or even has all the prime numbers on the die. So that's 2, 3, and 5. And all the evens. So 2, 4, 6. And your repeats, though, we don't write them twice. So 2 is only written once, even though he's part of both groups. So that's the union, which is going to be tied with or. The symbol for union, I think, is pretty easy because it looks like a U. So this would be E is the event A or B, A union B. Again, this symbol stands for union, and I think that's a pretty easy thing to remember because it looks like a U. It's not a U, but it looks like a U. So A or B. Get all the stuff from A, all the stuff from B. Next up is the intersection. The event A and B. This consists of outcomes that are in both events, but they have to be in both events in order to include them. So A and B. For example, dealing a red card and a 2 in a deck of cards, it only has 2 possibilities. The 2 of hearts and 2 of diamonds. Those are the only 2 cards that are both the number 2 and red. So when it's and, you have to belong to both groups. And I would say your understanding of how or and works is not helpful here. The way you would, like in your day-to-day life, use the word and use the word or doesn't really fit with the mathematical definition for and or. It's kind of switched. So for example, if I said tonight you're going to have steak and lobster, in a mathematical sense you would have nothing because there's no overlap between steak and lobster. So if tonight you're having steak and lobster, you get nothing. But if I say tonight you're going to have steak or lobster, you get both of them. That's how it works mathematically. And you have to belong into both groups, or you get both groups. The symbol for intersection is this upside down union symbol. It looks kind of like an in, and for whatever reason that to me has tied into intersection. I'm like, oh yeah, it's an in, intersection. I don't know why. That's not mathematical. That just has stuck with me since I learned that symbol. It also looks kind of like an in from the word like and. So that helps me out too. Like and has an in it. And this looks like, a little lowercase n. It's not, but it looks like it. So E is the event A and B. So if I were a student, when I'm like first learning this, I might make a note that and or are not like intuitive necessarily. The definition that you have for the word and is probably not going to help you in this class. You need to kind of quickly throw that away for this new definition when it comes to logic and mathematics. Okay, next up, we have mutually exclusive or disjoint. These are synonymous words. They mean the same thing. So mutually exclusive, disjoint mean the same thing. And this is when 2 events have no outcomes in common. There's no shared space between them. So Monday, Tuesday are mutually exclusive. There's no overlap. You're either Monday or you're Tuesday. You're never both. You can't be both. As soon as it switches to Tuesday, you're no longer Monday. So mutually exclusive or disjoint events have no intersection. So for example, if you're rolling a die one time and you're trying to get a 2 or a 5, those are mutually exclusive events. You would only get one of those. You can't get a 2 and a 5 at the same time. So mutually exclusive or disjoint. You will see these words switched out, and so you need to make sure you know both. If it's a quiz or something like that or a test, you can always Google. If it says like, which of these are mutually exclusive, you can Google mutually exclusive if you forget that term. That's okay. Hopefully you'll do enough practice that it's going to become second nature. You'll know, like, oh yeah, I know what that means. But if you forget it, just Google it. It's a simple concept once you know what it's saying. There's nothing in common between the two. Finally today, we're going to focus on Venn diagrams. I mean, we have plenty more to do, but this is like the final aspect before we start putting it into practice. You guys have seen Venn diagrams before. You know Venn diagrams. You have like a crazy Friday night with you and your friends where you're making a Venn diagram. You know how it goes. Is that just me? So Venn diagrams are used to display relationships between events. They're really helpful in calculating probabilities, according to the slide. So here is a Venn diagram with event A. The rectangle, this little, like on my screen, it looks kind of beige-ish rectangle. That's the sample space. That's everything possible. And inside the sample space is the event A. So sample space would be everything, and then inside of it would be the event A. So with our definition of complement, notice that the sample space has been shaded except for where A was, and that's A complement. That's the complement of A. That's everything that is not A. When you see the word complement, you can also think of the word not. So this is not A. The circle is A, so this is not A. Here's A, here's not A. Here's the Venn diagram for A or B. Notice that we shade everything that is A, everything that is B, and we also shade this intersection of A and B. So OR gives you all of the stuff A has, all the stuff B has, including their intersection. And again, your understanding of the word OR versus AND is probably not going to be helpful here. OR looks like this. I'll show you what AND looks like. This is AND. This is A and B. It's only this little sliver right here because that's the event that is both A and B. I promise you, it makes sense, but your version of what AND means in your head is probably not going to help you. Maybe it does, but for me at least, I always think, well, and if you have this and that, you got both. It's not a, so the question was, is it saying that they're combined? I would say that's the understanding we have for and when we say and, like it's a combo. In mathematics though, and is saying that they're a member of both groups. They are a member of A and B. So the only people that are members of both A and B are this little sliver right here. When it comes to or, they're members of A or they're members of B, which means that you would shade everything that's A, because that does satisfy what I said, members of A, and you shade everything that's B. So hopefully that makes sense. Cool. Yeah, no problem. Thanks for the question. Here would be a visual version of a disjoint set of events or a mutually exclusive set of events. Notice that there's no overlap between A and B. There's no intersection. So the intersection of A and B would be nothing. It'd be null. It'd be zero. Okay, so this is where we're going to start getting into describing regions. These can be, I think, kind of useful to, like, maybe if you're watching the video, pause the video and try to answer this before you see the response up there. And if you're not watching the video, if you're in class right now and you don't have the ability to pause me, no matter how much you try, in that case, you can always go back and like redo these. The PowerPoint is posted. I think these are really useful to try and figure out, all right, how does this work exactly? So if you wanted to describe this shaded region, we would say that this is calculus. It's definitely a calculus region, except we're not including stat. So it'd be calculus and not statistics. This is calculus and not statistics. Here's another one. You guys could try that. I'll pause for just a second. All right. Statistics and not calculus. I forgot how to say the statistics word. So hard. I don't run into it very often. So statistics and not calculus. All right, try this one. So this would be the intersection, statistics and calculus, straight definition of and, statistics and calculus. These would be people that are taking statistics and calculus. So if you think about, if you want to have like something conceptual, these are people that are taking statistics and calculus. They're in both classes. All right, this one has a couple of answers that would be acceptable. I'll try and go through at least two of them. So they've said not statistics or calculus. And notice these parentheses. Parentheses work the same way you guys are used to. There's a distributive idea here. So it's both not statistics and not calculus. And that's actually the other answer that would have been fine. This is a little region right here is not statistics and not calculus. You could also say not, and then my version has no parentheses. But this is good. Not statistics or calculus in parentheses. Okay, so this would be an example of where we could use a Venn diagram to find probability. So there's 200 students at this school. It's a very small school. 50 students are taking statistics and calculus. So they've given us this middle region right here. 50 students have taken or are taking statistics and calculus. There's a total of 90 students taking statistics. So this whole circle is 90. And there's a total of 110 taking calculus. This whole circle is 110. And so what we're going to do is put the values in there. So notice that we have 50 taking stats and calculus, which leaves a remaining 40 just taking statistics. So this whole circle adds to be the 90 that we've been told about. There are a total of 90 students taking statistics, and we see that here. This is 60 students are just taking calculus because we have 110 taking both. Or sorry, not taking both, taking calculus. And that leaves 50 remaining for this, this rest of the sample space here. This is the complement of stats and calculus. So we got that because there's 40, 50, and 60. That's 150. And there's 200 total students. So there's 50 remaining. So now we could ask, in this case, how many students are in statistics? Well, looking at this, it seems like there are 80. This is a different set of numbers that seem kind of confusing. So this was one problem, I guess. Sorry, I didn't like preface that well. Here's the end of this problem. And then we go to this one, brand new numbers. This is going the other direction. So how many students are taking statistics? That'd be 80. How many students are in calculus? That'd be 110. Putting these together. How many students are only taking calculus? That'd be 80. These guys right there. How many students are taking statistics and calculus? And you got to be careful here. Remember, that's saying they're in both classes. They are taking both statistics and calculus. So that's these 30. How many students are not taking statistics or calculus? And so that's going to be the 40. How many students are in the school altogether? We would just add these up. So it's 130, 160, 200. None of the concepts we're covering in this unit are particularly difficult, but there's a lot of them. And they have like your intuitive understanding of them is probably not always correct. So it's really important you do practice in this unit. So that's the end of this lesson for today. We can maybe look at a practice problem or two, and then I'll let you guys kind of work, and I will stop the video after that. So let's do a couple of these things on your homework / today's worksheet. So I think the first thing it asks for is a tree diagram, which we have not done before. I don't think. Okay. So it says, consider the chance experiment in which the type of transmission, automatic or manual, is recorded for each of the next 2 car purchases from a certain dealership. So we have our first purchase, and this could be an automatic or a manual car. It's the first possibility. And after that first automatic or first manual car is sold, the second one can also be automatic or manual. This would be our second possibility, our second car. Same thing for the manual. So this is called a tree diagram. There's not much to it. It just, you start off with your first stage, basically. What are the options for that first stage? You go on to your second stage, and then it kind of branches off. It looks like a tree. And I'm certain you've done these before, maybe like in 7th grade or something like that with the basic probability units. So you've probably seen these before. But just in case, if you were to look at this endpoint right here, that stands for M and then A. That's like what that means. When you're looking at that A, it stands for M and then A. So now we want to come up with the sample space. These are all the possibilities. So we'd say S, our sample space, is equal to, and we're just looking at these final outcomes. So one possibility is you get an automatic that you've sold. You could have also sold an automatic manual. You could have also sold a manual automatic or a manual manual. If you're selling 2 cars, these are all the possibilities for those 2 cars. They could be both automatic, one's automatic manual, or manual automatic, or they're both manual. So that's our sample space. We'll do maybe one more of these. So it says, list the outcomes in each of the following events. Which of the events are simple events, which means that they only have one outcome. So B is the event that at least one car, has an automatic transmission. So B is equal to, and then I want to look through my sample space, or I can even look at my tree diagram, for instances where we have at least one automatic transmission. So AA definitely has at least one. AM also has one automatic, or at least one automatic. MA does as well, but MM would not be in this event. That's about it. Later on, if you want to see where this is going to go, is I could start asking you for probability. I could say, like, what's the probability of event B occurring? Consider, like, this would only work if these are all equally likely. But we would take all the outcomes in B, which were 3. There were 3 outcomes in B. And we would divide it by the total outcomes, 4. And this only works if they're all equally likely. We'll talk about that in the future. But there would be a 75% chance of selling at least one automatic transmission. That's kind of where this is going to go. All right. So there's a couple more sample space event questions, and then there's some Venn diagram questions. The keys, of course, posted. You should definitely try and learn this stuff because we're going to kind of keep moving forward. This is not like that box plot unit where we kind of lingered with the 5-number summary for gosh knows how long. This one's going to keep kind of moving. We'll get some new information almost every class. All right.